Hello everyone, welcome to our final report for the biomedical question answering system. This system is designed by the Team 6 of 14.4, and we have 5 team members: is Ray Wang, Victor Zhou, Carol Chen, Hua Tang, and me, Yan Zhao. In this final report, I will introduce our overall system design, the evaluation of our performance, and the further improvement. Now, as we can see that our final report consists of 5 important components. The first 4 of them is about the system functionality, which is about what we learned from the Design and Engineering Intelligent Information System course, and which talked about the Apache UEMA framework and the software engineering. Furthermore, we introduce the Scrum develop process into our project, including the burn-on chat and sprint backlog to help to ensure the coherence of our project during every iteration. So what is the purpose of our system? The objective of our system is to generate an appropriate yes or no question for the given yes or no answer for the given question. And as can be seen in the following, that a given question is memory print approved by the United States, and we can give the answer like yes. So for the software engineering perspective, the user case diagram is pointed out in this slide. As we can see that there are 2 interactions between the user and the system. The first is the user give the question into our system, and our system will give the answer back into the user. Meanwhile, our system has an interaction with the outside web service to collect the relevant biomedical answer information for our system to pre-process. To maintain the process of our project, 3 milestones have been set at the very first place. First is the minimum viable prototype that needs to retrieve the concepts, documents, and triple for our system. Then is the snippets retrieval to help to find the candidates of the answers. And the third milestone is to exact answer generation to give the exact yes or no answer. So based on the 3 milestones we set, we designed our architecture like this. The architecture is based on the Apache UEMA framework and is also the collection processing engine pipeline. First, the collection reader reads the question into our system. Then the system passes the question to the aggregate analysis engine and let the annotator to save the result into the common analysis system annotation. This is the main part of our system that to fulfill the 3 milestones. And as we can see in the aggregate analysis engine, the atomic and complex query combine together to retrieve the concepts, documents, and triples. Then we pass the documents into the snippets annotator to find the candidate answers. And then we pass the candidate our performance and output the answer back to the user, and which were introduced by my teammates in later slides. So the critical issue for the very first question is that we need to understand the meaning of the question. We apply several NLP techniques to the question into the query. As we can see, the questions is converted into autonomic query by removing punctuations, removing stop words, and doing stemming. Then we use a strategy including adding operations like AND to combine the different terms, and LinPipe to reselect different terms to generate complex query. We then use this complex query to search for the web and to get the quite precise concept and add these concepts back into the autonomic query to help us to find the documents and to ensure the correctness of our documents retrieval. And based on the documents we retrieved, we passed the documents into the snippets annotator. In the snippets retrieval section, we introduced two help classes, like the snippet retrieval helper and the similarity calculation to help snippet retrieval. The first class is used to collect the article from the web based on the document we retrieved, and the article is chunked into different sentences. Then, by the second class, we calculate the cosine similarity of the original query and the snippets we retrieved, and re-rank the snippets and pass it into the answer generation annotator. And in the answer generation annotator, we introduce our strategy that we include a threshold on the similarity, and if the candidate answer is larger than the threshold, we can think that for this question we should get a yes answer. So here is the performance, and I will introduce my teammates Huatang to introduce the performance of our system.
Here are performance in milestone 1 and milestone 2. In milestone 1, we do concept annotation, document annotation, and the triple annotation. The figure is evaluation using MAP at the end of milestone 1. As for milestone 2, we do snippet retrieval based on documents we get from the milestone 1. So these are the sentences in snippets. Let's look at our performance in query processing. We try different ways and use different concept score thresholds to process query questions into queries. The first figure is performance without eliminated stopwords, and the second figure is after eliminated stopwords in the queries. From these two figures, you can see that the performance in the second one has been improved, both in concept and the documents. After summarizing the performance, we decide to eliminate stopwords and choose the threshold as the 0.1, and this is the figure of our final performance. According to performance we previously showed, we find that it doesn't reach our expectations, so we chase back and found out some problems in our system, like the low MAP in document annotation, which can result to few snippets and even no answers. And also the MAP of triple is 0. Since we know what problem in our system, we come up with several ways to improve it. The first and the most important one is query extension. There are 3 steps in the query extension. The first step is we need to pick out the biological terms in query text using NumPy, because our system is focusing on the biological questions. And the second step is to use advanced combination strategy for received concept, document, and the triple from different complex query concept annotators. The last step is to add the concept into updated query text and then use it to search document and triple. Another aspect to improve our system is to rank document. Those documents we get is not ordered, so the top 10 documents may not be the most related to our questions. So we need to use some strategy to rank those documents and get the most relevant ones, so that the snippets and the answer could be more accurate. As for the strategies to do that, we can use the cosine similarity or BM25.
So during the project, we introduced the Scrum process development to help improve the efficiency of our work. Firstly, we we create the product backlog based on the product owner, Professor Ravi, and we detail the tasks of the product backlog. And then we give different priority into different tasks. As we can see that for generating the exact answer, we give this task a very high priority because this is the main purpose of our system design. And then for the snippets and concepts retrieval, we give them a relevant second and 3 priority, since this is the for choosing the candidates of our exact answer, and it's very important to fulfill our system. And for the triple retrieval, we give it the 6th priority, since we did not use the triples much in retrieving the exact answer in our system design. And based on the task in the product, we during every sprint meeting, we divide and detail the task into different sprint tasks, as we can see in the sprint backlog. For the generation of exact answer, we detail this task into an answer generation annotator implementation, and we divide this task to different team members to fulfill. And for another example, like the system process question, we divide this task into 4 different detailed tasks, like the collection reader, the question annotator, and etc. And we divide the 4 different tasks into different team members to help improve the efficiency of our work. And the sprint burn-down chart is shown on the slide. As we can see that the blue line represents for the estimated of our job, and the red one is the actual work of our job. And during the beginning of every sprint meeting, we are not very familiar with our own tasks, so we start our work very slow, and at the end of every sprint, we work harder and to fulfill to get to the deadline of our sprint. So we get very hard work. So as we can see, there are 3 sprints, and we work hard in the end of every sprint and fulfill our system design. For the whole project retrospective, every team members give their view of the whole project and describe what happened in this project and their purpose and how to improve after this project. Take myself like an example, in the fourth Yanzhou, I helped to build the pipeline of the whole system, and mainly in charge of the consumer implementation and evaluate the answer retrieved. And I do this because I try to learn new knowledge during the system design, and I think I need to work harder on the task and to cooperate more with the team members and learn more to manage my own work. So this is the whole introduce of our system. Thank you.